Alright, draft physics video, sort of a different kind of video this time. I thought we would discuss Ken's, well, some other guy's Ferrocell, and then Ken has redone it to make a Supercell, which doesn't look all that different, you know. But anyway, so I'll show some images, and you know, I thought we could just go through the rigmarole of figuring out exactly how they do this thing. I mean, how does this thing work? Because it's not a real image of magnetism. It's this distortovision. And be interesting to be able to dissect how exactly the distortion takes place. Because it is interesting how the light does come out of the LEDs, it appears. These little streams are right where the LEDs are. You know, it's lots of, you know, nuance, then especially these patterns, you know. Lots of crap happening there, and hard to, you know, just say, oh yeah, I got exactly how that's happening. So we'll just stick with this image for now, I suppose. Alright, so one feature that seems sort of interesting is that, okay, so it's this idea of two layers of glass. There's this layer of ferrofluid that's mixed in a special way, something added to it. I would say something gluey, but whatever, olive oil, who knows. They won't tell the secret ingredient, and they're going to force, you know, us to figure it out for ourselves by, you know, trying different things. You know, I haven't jumped in and spent the $8 to buy some ferrofluid yet, but I suppose I should. I have some clay, you know, which is different, and I'm trying to extract the bits out of the clay just for to see if I could see if, you know, they're little small nano thingies or whatever, so see if I can make something out of that. But anyway, yeah, but, you know, this could be a really interesting tool if it did a better job of displaying the actual field lines rather than these distortions. So it's this thin layer between these two layer thicknesses of glass. Now the glass is really thick, like, you know, 3/8 of an inch thick, thick glass. So okay, why? You know, the first question. And the fact is that it also guarantees some distortion in the image, in the sense that the layer of glass doesn't permit the magnet to be in close contact with the magnetism. So it's kind of like, I guess, holding iron filings higher above a magnet, and maybe you'd get a different kind of pattern. To illustrate, yeah, so it's sort of like this thing, you know, it's a thickness of glass, and just this little thin layer is the place where all the action's happening. And then you have these little lights shining from both sides and all around. But yeah, so the magnet would sit up here, and so it's clearly that distance is not insignificant, significant distance, and you have to wonder why, you know. Because obviously if it was thinner glass, then you could use smaller magnets and get an effect. But you can't really use small magnets and get an effect because they're too far from the fluid to affect it. So, yeah, I just don't know enough about refraction in terms of, like, whether plain optical glass with a liquid layer between it, you know, creates all kinds of potential for distortion, but I just don't know enough about that. So the one thing that does occur to me, okay, the first thing that's obvious is when he's got a magnet below it, you'll get the same effect. So we know that the dark place is where the strongest attraction is. So the biggest amount of stuff clumps in the dark spots. I guess we do. It's not a very good example either, but it's okay. Well, it is sort of interesting because you always get these off-center thing of the poles. The poles are always represented off-center, and it's ovals, even with square magnets, which is also, you know, why. So that one. So the thing I could deduce, like I said, the thick glass is one question, like why. But the thing you can figure out is that the dark, okay, so this magnet was underneath, you have the same kind of effect, except there, you know, you get this, all this brightness right around the edge. Let's see if he has one of those in here somewhere. Underneath one. Yeah, the sphere thing is even a little weirder, but you know, you really know you're not getting a view of magnetism. Yeah, these are all on top, so not much you can do. Alright, so one thing I deduced anyway, so this is where the fluid collects. So the fluid, the magnetic part is dark. So it flows to where the strongest magnetism is, obviously. And its surface is reflective. So it blocks light, but it reflects light. So that's how I'm seeing it. There's always a bright line around anywhere where there's a dark. So the bright is basically the reflection off of where there's a bunch of dark. That's one thing I figured out. The other thing that seems obvious is once you do this, especially with the thick glass, the glass can't at all bend. So the pressure of this fluid has to change as all the heavy bits of the fluid move towards the magnet. And that forces the lighter ends to have less fluid, so to speak, you know, less substance. And so what I'm thinking this is the actual pulling away, you know, when so the glass rises just a hair and the fluid pulls away, it's not consistent anymore. And that might be what these some part of what's creating these spirals is the fact that there's a lack of fluid there. So because there's not enough fluid, the fluid adhesion is the only thing holding the fluid together. So it just goes top to bottom between the two layers of glass. So if you thought of this little thin space between the layers of glass, if there's a lack of fluid density, then the fluid would, you know, or the thicker parts of the fluid would start to maybe do something like that, you know, where they're clinging to this surface, but they're running out of density to do it, you know, kind of a thing. And that does appear to be something like that in terms of how the light's reflecting. It does have that kind of look to it of a, you know, something that's pointed on the top and flares at the bottom. So that certainly fits. Let's see, what else can I deduce? So the edge of the magnet, the reason why the pole looks the way it does is because they're only looking at one part of the, you know, this section. So the rays are coming out straight from the end of the magnet. And it really just depends on where you are as a viewer, you know, what you see. So if you're looking from this angle, which this is what the cell is looking at. It's always looking from an angle where this glass is separating the two. So it's not getting a solid view of the strongest part of the magnet. But these would be the strong lines going this way. Is that what I want to say? Yeah, I'm trying to remember. It's really just seeing the reflected view. So you're just seeing the opposite of, you're seeing this pattern on the ferrocell. There we go. Okay. So you're looking at it from this side. So this is the glass. And so you're seeing the magnet here. The fluid is down here. The fluid is only getting this portion of the strongest part of the magnet. It's not getting the full force of it. So that's why it's coming off at an angle and ends up misshapen. It's because it's only getting a portion, a distorted portion of the rays of magnetism are reaching it. All these are just getting too spread out. The R squared thing takes effect out here, and the strength of the magnetism isn't strong enough. So that's what this is. This is like the angle. They're just pulling the magnetic elements towards it, and then it's doing this reflection thing. Now this second line, I don't have a, you know, I don't know. Clearly that could be the second line of a regular field line. So if you had regular field lines, they'd be coming out and they would have, they'd be arcing around each other, like, this towards the magnet. So that could be this effect. So here's your first field line, and that's hard, filled. And then the second one is just a line. And then they're just lines afterward. So that's your first real field line. And then it's doing this this bright reflection again. And obviously this reflection isn't as bright because of this heavy brightness here. So that's, I guess, the other rule here is the brightness will go down depending on how many of these rings will be revealed, and I don't know if that really explains the one in the center. The center one is really interesting. Let's see if he's got one of those on here. The full ring. Yeah, the full ring is really... Alright. But, you obviously have this. This is on top. But the fact is that if this was on the bottom, you'd have the same effect in the sense that the magnet would look dark. And then you'd have this bright edge, which, again, as I'm saying, is just this reflection thing. But there's still enough light getting all the way to the center, to create all of this stuff. So, yeah, I don't have a complete explanation for how that much light gets there when you have this bright ring around here. But clearly there's, could be lots of places where there's gaps or whatever. So that's a little, more than I can manage in this one video. But clearly these are all just distortions, and like I said, it'd be really nice to have a more scientific tool, one that isn't doing this distorting. It would just be scientifically useful to be able to see field lines in finer grain like this. Because the problem with regular ferrous material is that it's clumpy, and so it makes big field lines. The power of this ferrofluid is that it can make small field lines. It has the potential to do that. To reveal it in a finer grain, because the field lines are arbitrary. The round ones are kind of arbitrary. The ones that aren't arbitrary are the rays going out. So anyway, but Ken did some sort of religious explanation of the whole thing in terms of, well, I'll play some of this. Is just like, what? This isn't an explanation of anything. Another ad, unfortunately. This thing's also not loading.
I'm incredibly tired. I built 4 Supercells. I'm thin. And the answer to that is as simple as Mother Nature itself. The only thing that defines mass, magnitude, volume, or even holographic depth, or genuine depth, in the entire universe is magnetism and magnetism only. You couple that with the fact that what defines it...
Holographic depth. Do I have holographic depth? I have a magnet here. It doesn't have any holographic depth.
Magnet is field coherency. So not only have magnetism in the neodymium iron boron, but it is all...
Well, anyway, so field coherency again. Just a bunch of talk, and nothing that actually explains function. How any of these pretty pictures have anything to do with magnetic attraction. I guess that would be a more interesting thing that he doesn't do too much, is to bring 2 magnets, from far away and bring them closer and see some of the changes that take place, and do that in kind of a slow manner. He doesn't do very good experiments, frankly. Instead he breaks a magnet and puts that on there. Like, doesn't help much. But anyway, so it is a curious toy. And but it really should be, it shouldn't be sold as if it's showing something that's real, because it's a distortion of the reality. And it needs to be properly understood as that. And maybe understood by somebody who really wants to create something that actually does justice to magnetism, and actually creates something that shows it for what it is, instead of for what it isn't. So anyway, enough of a video.